All right, so today we're going to be looking at 5.2 sine and cosine functions. Now, before we begin, we're just going to take out our pencils, and without our calculators, we want to write down the exact values of sine theta. Okay, so we're just going to do some investigation. We're going to think back to chapter 4 when we were looking at the unit circle, and we're going to think back as to sine. Remember, sine is second. And we're going to write down all of the exact values that we know from 0 to 360. Okay, so take a moment to do that. Once you've filled in this entire row, I want you to use your calculator and actually sub in the values sine 0, sine 30, and you're going to round that to just 1, maybe 2 decimal places. Okay, go for that. I'll give you a couple minutes to do that. Did you want a handout? Yeah, go for it. Okay, that's okay. Yeah, valid. No, 270. Right? 270 is your third, after your third quadrant. Yeah, right? Some people needing to draw a unit circle, and that's okay. Okay, so once you finish that first column, head on to the second one with your calculator. Okay, I'm going to give you one more minute just to do that first row, and then we're going to do the second one together. Does anyone need more time for the first row? Okay, so let's go through it together. So sine of 0, exact values is 0. Just yell it out, guys. 30 degrees. Oh, that was a lot of mumblies. Okay, so remember our 30 degrees in our first quadrant, sine is second. Is it root 3 over 2 or is it a half? Good. 60? Oh, and I didn't put 90 there. So I'm sorry, I didn't put 45 in there. So we're just going right to 60. So root 3 over 2, 90. 1, right? Because you're going over 0, up 1. So sine of 90 is 1. 120, root 3 over 2. Is it positive or negative? Positive. 150, 180. Good. 210, negative. So now we're looking at negative y values. Will the rest of this be positive or negative? Negative, because we know now all of our y values are going to be going into the quadrant number 3. Okay, so 240 is going to be root 3 over 2. 270, Oh, sorry, thank you. Negative root 3 over 2, 270. Negative 1, 300. 330. And last, 360. Good. Okay, so when you enter these values into your calculator, you're just going to sub in the value for theta. So for example, you're going to enter sine 0.5. And the reason why you're doing this is just to get an approximation in the second column. Okay, why don't we do it together then? Okay, so sine of 0 is still going to be 0. Sine of 30. Did anyone get sine of 30 already? Oh, sorry, this is half. So 0.5. Root 3 over 2 is 0.9. Okay, so you can see as we look at our values, we have 0, 0.5, 0.9. We're getting up to 1. And we have the number again. Do I need to enter this back into my calculator? No, we have that value already. So we're back at 0.9, 0.5, 0, negative 0.5, negative 0.9, negative 1, negative 0.9, again, negative 0.5, 0. Just by looking at our values, talk to your partner, make a prediction. Will this be periodic or not periodic? Talk to your partner just looking at values. Answer why. Okay, so how do we feel about this? Who thinks this will not be periodic? Who thinks it'll be periodic? Okay, why? What indicators tell you just by looking at values whether it's going to be periodic? Maria? Yeah, we're looking for repeated Y value digits, right? That was something that we talked about yesterday. So let's actually graph this and let's see whether the graph of this is periodic. So remember that this is 90, so each square or each box is going to represent how much? How many degrees? 30. So 30, we're at a half. 60, we're at 0.9, so just put that close to 1. We're just estimating here. 90 is at 1. We come back down to 0.9, 0.5. 180 is going to be at 0. Then negative 0.5, negative 0.9, negative 1, and we're just repeating that up to 360. Okay, so through those points, I want you to draw a smooth curve as best you can. Okay, so now we have a graph between 0 and 360. We want to make some guesses as to what's going to happen before 0. So when we're looking at x values that are less than 0 and x values that are greater than 360. So we're going to put in a value that's greater than 360. And because we're going up by 30 degrees, let's test 390. Put that into your calculator. Before you push equals, talk to your partner. What are you predicting that you're going to see? Make a prediction. And then check to see if you're correct. Okay, I like the conversation I'm hearing. So Who put in 390 in their calculator already? So first, before you push equals, what were you predicting that you were going to see? Say it out loud. 0.5. Is that what you ended up getting? Good. And if we went another 30 degrees, so 390 plus 30 would give you 420 degrees, what would your prediction be? 0.9. Put that in. Tell me if that's what you get. Okay, so what can we figure out about, number one, how many cycles did we just complete between 0 and 360? Okay, so what are we noticing now that we're starting to see a repeat? Is this periodic? Yes. Okay, so again, we're going to try and fill out this graph using the prediction that we have of beyond 360. Now, before we continue it, talk with your partner again. What are you predicting the end of this next cycle to be? Chat with your partner. What are you predicting? And then answer why. What are you predicting the end of the next cycle to be and why? Okay. I like that I'm getting like hand signals. Okay, pause. Tell me what we discussed. Who wants to share? Fatima's sharing with her fingers. Okay, tell me what you figured out, Fatima. 720 is the end of cycle 2. Did we all get that? Okay, so let's fill in the rest between 360, 720, giving your prediction. And then once you've done that, see if you can extend that in the negative direction, okay? It's going to be a little bit different because you're going to be going in an opposite direction, but give that a try and then check with your partner. Okay, go for it. Really try and round out the values so it doesn't look like zigzags. Okay, we don't want to have any points. We want a nice smooth curve. And because we know this is continuous, you can also draw arrows on the ends of your curve to show that it's continuous. Okay. Now, take out a highlighter, and if you need some, I have some here. Now, I want you with your fingers to put your finger at the beginning of one cycle. It can be anywhere. You can start at 0, you can start at -90, you can start at 90, and then I want you to put your other finger at the end of a cycle. Okay? Check with your partner, see whether you agree. Check your partner's work because you might all be in different places. Okay? So once you've checked with your partner, I want you to move your finger to a new spot and see whether you can find the end of another cycle. So you might be here, you might be here, you might be here. So for example, if my finger, pause, if my finger is on 180, where would the end of the cycle be? Okay, so 540. So let's try another one. If my finger is at negative 180, where would the end of the cycle be? Just yell it out, anyone, everyone. 180. Okay, another one. Negative 90, where would the end of one cycle be? Good, and let's do one more. Let's do 270, end of one cycle. Good, 630. Okay, now with your highlighter, I want you to highlight one cycle. I always like to start at 0, 0, but you might choose to start at some other spot. But remember, it always ends when the pattern is about to repeat again. Okay? So share it with your partner. Make sure you're both on the same page. Okay. Now, pause for one moment. Let's look up here. Would it be okay? Pause. Would it be okay if I said that this was one cycle? So look up here. I'm going to trace this, and you tell me if this would be correct. So this here is one cycle, right? Because I end back in the same spot. Now, what's incorrect about what I've done? Khalid? Oh, I went for 2 cycles. How do you know? The closest one, like here? No. Be more exact in your wording. 270. Okay? So this would be one cycle. Sometimes we mistake and we think, oh, well, we're back in the same place, so that must be one cycle. What about here? If I'm starting at 0, 0, would this be one cycle? Why? Emil. The pattern's still going. What do you mean by that? But I ended up back at the same spot. Isn't that okay? No? Okay, so tell me why. Haria. Yeah, so both of what you and Emil are saying is that if I continue in my X value, my Y value is not going to continue to repeat. Okay, so even though these seem like very simple, straightforward answers, remember, you guys have to be able to explain that and communicate that on your quiz. Okay, so take the time to actually articulate it either out loud to your partner, yourself, write it down, something. Take a minute to do that. How do you define one cycle? How do you define one cycle? Talk to your partner, write it down. How do you define one cycle? Articulate it using the keywords that we've learned. You guys done? Yeah? Okay. Pause. Are we good with that? Okay. Let's actually try and put some of our graph into characteristics here. So how many degrees? So now we're going back to degrees. Oh, actually before that, I want to show you guys this animation that I found that I think is kind of cool. So take a look here. So we looked at the unit circle last unit. Arshan, do you guys have a question for me? Okay. Okay. Do you need another minute to talk about it? Okay. So this is our unit circle, which we're used to seeing. Our A value is our degrees. Okay. So just as you guys have done, as our angle increases, so now we're at 30, 60, and so on, this is the curve that you've created. Okay. So as our A value increases, we're looking to see what our Y value is, and we're actually drawing this out as a pattern where here is our change in degrees, and now we're looking at our change in y. So this is for one full cycle. What would the period of this function be? 360, okay? So let's write that down. Our period is going to be 360 degrees. So just like in chapter 4, every time you open your calculator, you have to make sure that you are set to degrees and not radians, okay? So we're still making sure that we're set into degrees. What is our maximum value for this curve? What's our max value? 1, okay? Our max value is 1. We can also write this as y equals 1. And what's our minimum value? Y equals -1. Now, our amplitude, this is something that if you need this sheet from yesterday, we can look at, right? We're looking at our median line. So I always think of a skewer inside a kebab is in the middle of the meat or whatever it's going to be. That's like what the median is, right? The median to the very max, the median to the very min. So what would our amplitude be in this case? Here's our median line. Our maximum value is going to be 1. How else could I calculate amplitude? Who remembers the equation from yesterday? Aish. Yeah. So our max, which is 1, minus our min, which is -1. So it's going to be 1 minus -1 is 2, divided by 2 is 1. So our amplitude, A equals 1. What's our domain here? Assuming that this is continuous and infinite, Abdul Basit? Good. So XER, also do the range, Abdul Basit. Good. Although usually I like to read from left to right. So when you read it, just do your less than first and then your greater than, okay? What's our y-intercept? Do we have more than 1? No, we just have the 1. Our y-intercept is y equals 0. Okay. Now, you have just graphed your first sine wave. Okay, so this is our graph for y equals sine theta. It's going to be the bread and butter for what we're going to do after the break. We're going to draw a lot of these, so I really want you to get used to what this curve looks like. So I put some tips here for you. Okay, do you guys have any questions so far? Can everyone show me thumbs? How does this feel so far? Okay, good. That's good. Now, let's do some tips then. Is that a question? Aish. How do we know when it's one cycle? Okay, let me give the tips first, and then you tell me if I've answered that question for you, okay? So, tips, we're going to look at 2 curves. We're going to look at sine, and we're going to look at cos. I want you to be able to differentiate the 2. So, our first tip for sine always has start, middle, and end on 0. Okay, so your start, middle, and end points are always going to be on the 0 line. Okay, so start, middle, end, 0. I don't know why I put or here, 0. Okay, so this is always going to be 0. And when I say start, middle, end, the reason why I think about it this way is because when you draw one cycle, it's going to be at 0 degrees, 360 degrees, and then your middle is going to be 180 degrees. Okay, hurry up. Yes, however, for this particular case, sine always starts at 0, 0. So later on when we do transformations after the break, sometimes your cycle is not going to be 360, it might be 180. But the good thing about thinking about this way is even when we have compressions or stretches, if you know the end of one cycle, the middle value will stay the same. So for example, if I have 0 and 360, and this is kind of jumping ahead a bit, 180 will be your middle. If one period is 0 to 180, your midpoint is going to be at 90. Okay? If your cycle is 0 to 720, your midpoint is going to be at 360. Okay, so that's a reason why I like to remind us that all you need to know is the beginning and the end of one cycle for sine. That's the most important. Okay, and here your theta intercepts, I actually already wrote it here, are going to be 0, 180 degrees, and 360 degrees. So our first quarter always goes up. Our third quarter always goes down. Okay, so that is a tip for how you're always going to draw your sine curve no matter what. Okay, so here I have a little grid for us, and we're just going to practice this here. So we're going to imagine it doesn't matter where the median line is. Later on, when we do transformations, we might have to translate 4 units up or 4 units down. Wherever it is, you find your median line. You always determine the beginning of the cycle. This could be 0. This could be 90 degrees. Whatever it's going to be, you start at the very beginning, and then you put a point at the very end. Okay? And again, doesn't matter how big your cycle is. The next step is you put your next point in the middle. First quarter, you go up. Third quarter, you go down. So you're going to put first quarter going up, third quarter going down, and then you're going to draw a smooth curve. Now, when I say smooth curve, sometimes we draw funky things like pumpkin teeth. No, we don't want pumpkin teeth, okay? We don't want this to look like Halloween with pumpkin teeth. We also don't want octopus. These are two curves that are incorrect. We don't want zigzags, pumpkin teeth, that are very pointy, because this is not a smooth curve. And this curve, look, parts of this would not even be a function, right? Because we have straight lines here. So we don't want that either. We want a nice smooth curve. Okay? So just again, sine, median, middle, first quarter up, third quarter down. Okay, show me thumbs. How do we feel about that? Good. Okay, so flip the page. So we've seen this entire page before with sine, and now we're going to do it with cos. Let's see if we can do it a little bit quicker. I want you guys to fill in cos theta. You know what to do for sine theta. Cos theta exact values and cos theta to 1 decimal. You will see numbers that you're familiar with, and then I want you to graph it. Don't do the chart. We will do that part together. Okay, go for it. I'll give you, let's say, 3 minutes. values after what? Quadrant number 2 and quadrant number 3. So just make sure that quadrant number 2 and 3, you're writing in those values are negative. Okay, whenever you're finished with the chart, you can start graphing. How much more time do we need? Can I say 2 minutes? Is that enough? Quadrant number 2 and 3 negatives. Okay, so 1 more minute, and then I'll meet you at the end of graphic. I need to fill mine in as well. Okay, so those of you who are still graphing, you might notice that one cycle starts at a different spot. Where are we starting the beginning of a cycle now? What's our y-intercept? 1. Okay, so let's write that in. For y-intercept, we have y equals 1. Okay, we're going to kind of do this in different orders just so that we can really see the differences between cos theta and sine theta. Okay, so the beginning and end of one cycle is here. I'm just going to show you how I like to graph this, and similar tips to what I showed you on cos theta, but this time I'm actually going to show you on a proper graph. So just pause what you're doing and take a look up here. So I'm about to draw the next cycle. So what I do is I put one point at the beginning of one cycle, and I put a point at the end of one cycle. So it makes sense that they're both going to have the same y value, right? Like it wouldn't make sense if I had the end of one cycle here. Do we all agree with that? Okay. Now, I know that the beginning of and the end of one cycle is at 1. The middle is going to be at -1. So I have my to aim for. My first quarter and my third quarter this time are on 0, 0. Okay, and if you want to, you can add these additional points just for this graph while we're getting used to it to kind of round out your curve. But realistically, the beginning, middle, end, and any type of first, third quarter are the most important points, and they're the ones that I always want to see on your graphs, okay? So I'm going to extend my graph. And if you haven't already, please use a highlighter and highlight one period. Now, 0.5 and 0.9 are only points that we're doing now while we're investigating. From this point onward, I only need to see when you're going to be hitting any max, min, or median line. Okay, max, min, or median. So these points, the very bottom, and the median. Yeah, I don't need to see these in-between points. Like later on when we start doing transformations, remember how we always have like key points? Those are our key points. Okay, so again, let's highlight one cycle. Has everyone finished graphing, or do we need more time? Would anyone like more time? Yeah. Yes? Okay. Can you let me know when you're finished, please? And then we'll fill in this info. Who needs a device today? So, because these take a while to turn on, for our next activity, why don't you guys just turn it on and just get it ready so that you don't have to wait, okay? Does anyone else need a device? I brought 3 just in case. Okay. Emil, how are we doing? Do we still need time? 1 more minute, sure. Okay. Those of you who are finished graphing, try and see whether you can finish writing in this table, and then we're going to take it up together, okay? But challenge yourself, see if you can do it on your own, and then we'll discuss it. What's that? The last sinusoidal. Yeah, it's just like the shape of the curve, just like how we have parabola. I'm going to talk about it in a minute. Okay. All right, let's refocus together. Let's come back and let's answer some of these questions. So, a period. Everyone together. How much is 1 period for a cos curve? 360 degrees. Our max is 1. Our min is -1. I heard someone say 1. We're all in, okay. We're all in agreement. It's -1. Amplitude. Everyone together. 1. Domain. XCR. Same as before, right? Range. Same as before. What criteria or property has changed from sine to cos? So take a moment to look on your own first before we answer it as a class. What property has changed from sine to cos theta? Okay. Aisha? The y-intercept. So our y-intercept is the major difference here. All the other criteria are the same. Okay? So, you good? Okay. So let's do tips for graphing y equals cos theta. So start and end points are going to be at y equals 1. The theta intercepts occur at which degrees? 90 and 270 degrees, right? We're looking at the theta intercepts. So remember, we used to say x-intercepts. Now we're calling it theta intercepts. If I wanted to be more exact, I could also say theta is an element of all real numbers here. Where's our midpoint this time? The middle is not on the median anymore. Where is the middle of this one cycle? Y equals what altogether? -1, okay? And first and third quarter points this time are on 0, right? First and third are on 0. Khaled, is that okay? Okay. So again, we're going to do the same as before. Here's our median line. Our first, our last. So look up here, and then you can do it yourself. So first, last, middle goes down, first quarter on the median, third quarter on the median. Now, when I see these points, I'm so tempted to draw pumpkin teeth. Don't do pumpkin teeth. Okay? No pumpkin teeth here. So we want to have, remember, our points were 0.9 and 0.5. So we want to round this out as much as possible. Think about it more like a roller coaster, right? Whee! Up like this. Okay? So if you can see the next point, it says the graph y equals cos theta is sinusoidal. Can everyone try and say that word? So sinusoidal is like the shape. So just like how when we were looking at x squared, our graph is a parabola, that's the shape. This is sinusoidal, it's the shape. So anything with this shape is considered to be sinusoidal. Okay, now flip the page. I want you to try and practice a couple of these. I'm only going to ask you to do in class now 1 and 4. The rest of this page is going to be for homework. Okay, so try right now questions 1 and 4, and you're going to show them to me before you leave right now in class. So when you're done, just put your hand up and I'll come around. After those two, while we're waiting for everyone to finish, you can complete the rest of this if we have time, okay? And then we're gonna move on to something else. So when you've done those two, put your hand up. So all you're doing is you're just gonna try and see whether you can graph those yourself. Mohammed, were you able to turn it on? Yeah. Did it go quickly? Oh. Let's not spend too much time on this. I'm gonna say maybe 5 minutes or less. Okay, so just call me over. Before you call me over, check in with your partner. See whether you agree with each other. Yep. Guys, we're just doing 1 and 4. We're leaving the rest of the questions for at home practice. And remember, I don't need to see every single point. I only want to see your median, your max, and your mins. Median, max, mins. Prashant? Are you done? Oh, okay. And you don't even need to show me all those points. I just need to see median, max, and mins. Make it easier for yourself. Nice smooth curves. Really the purpose of doing this is so that we can practice having smooth sinusoidal curves. So you want to extend it for the full length of the graph. I have this like neighborhood. Oh, yeah. Yeah, no. I like that too. Okay, 2 more minutes. Great. And then just extend it in the other direction. So, the key things that we're looking for when we're doing our graphs. Number 1, have we extended our curves for the entire graph? Okay? Have we made smooth curves? Do we have pumpkin teeth? Do we have funky mountains? Okay, make sure your curves are smooth. That's really the purpose of these questions, those 2 things. And remind me again, sine starts where? We need to be confident with that. Sine starts where? Cos starts where? Okay? We need to remember that. That is our biggest thing that we're going to walk out of today remembering. Okay? Okay, so you can do the other ones while we're waiting, okay? Okay, I've checked about half of the class. So let's just take 1 more minute before we move on. Put your hand up and show me when you're done. So right away you didn't check your life. Something looks like easier. Okay. So this is very common. Okay. Now, when I look at this work, I'm like, okay, we have, we have our key points, we have our key point, we have our key point. Tell me, when you look at this graph, how can we improve this graph? What can we tell this person? Everyone look up here. What can we do? What suggestion, what feedback can we give this person? What smoother curves, okay? We don't want to see any points like this. Okay? All right. Sorry, now I made you ID yourself. Okay. So, lovely people, this is the rest of this page. Examples 1 and 2. This is what you're going to do at home. Please leave example 3 onward for me for tomorrow. Okay, we're going to do that together tomorrow. So, you can put this all away now. You can clear your desk. We're going to do a little activity. And this is where you need your devices, please. It is math related. Oh, here, use this Chromebook. Mika. Okay, let me stop the recording.